Fantastic. And we're live. Speakers, I would love to see your faces. Please turn yourselves on if you can and give us a smile. Awesome. So as you can see, we're going to be joined by some incredible speakers today. We have 8 in total, covering a range of topics varying from different elements of AI, alongside some DevOps talks, open source, and more. So looking forward to having all of you here with us this evening. For those of you who haven't come across Coding Black Females before this event, and I feel like all of you have come across Coding Black Females before, we are a non-profit organization focused on enabling more Black women to enter and progress in the tech industry. I'm Charlene, and I started Coding Black Females in 2017 so that we could have events like this and so that we could do things like this. But alongside talks like this and events like this that we're doing tonight, we also run a range of boot camps, we do mentor programs, and lots of activities happen. So do keep your eye out on everything that's happening with Coding Black Females. I'm going to make everybody smile whilst I take a quick photo, and then it's over to you, Bissy. 3, 2, 1. And one more. There we go. We have some pictures. Fantastic. So, Bissy, over to you for our first talk on AI, nature's algorithm.
Right. Thank you so much, Charlene. Hi, everyone. Okay, so quickly we'll be looking at artificial intelligence and nature's algorithms. We all know artificial intelligence is typically powered by different algorithms, right? A whole lot of algorithms are out there, right? That computers generally use in reasoning and decision making. But then a big chunk of them are actually powered by nature. They're actually powered, by natural phenomena and some natural functions. And they're pretty much ideal for solving complex, non-linear, and multi-objective, different, a wide variety of problems in artificial intelligence. So in this quick talk, we'll take a walk through some of these algorithms, how they work, what are they used for, and come with me, let's see what um, powers most of our AI, some AI tools and AI products out there. So we have neural networks as the first one. And yeah, it's powered by the human brain, right? The human brain itself is a complex network of neurons connected together, and they all work and function together. Naturally, you might not even be aware, but yeah, the human brain is made up of several neurons that are interconnected, and this inspired neural networks as an algorithm that powers AI as we know it right now. And typically they're used for complex reasoning, for complex decision making, and examples include your artificial neural networks, convolutional neural networks, recurrent neural networks, and a whole lot more. And then we have evolutionary algorithms. Evolutionary algorithms are actually based off and inspired by Charles Darwin's theory about genetics and how selection and how over time or over the years um, the best fit animal or best fit animal, or human actually, survives and is able to, it provides the most and even the best solution at the end of the day. So this algorithms are actually, it's based on survival of the fittest, and they are mostly used for optimization, right? Most AI algorithms some AI algorithms are actually conventional logic. They use conventional logic, but at the end of the day, right, when optimization is to be done, most times evolution algorithms come into play, and they're used for scheduling, for hyperparameter tuning, and quite a whole number of them. The examples here are genetic algorithms. We have evolutionary strategies as well. We also have evolution as well. Another class of nature-inspired algorithms are swarm intelligence, and these are based off tiny animals or tiny natural species that have some form of intelligence, and those intelligence have inspired algorithms used in artificial intelligence. And some of these species include the fish in the sea, the bees, ants, right? They all have been inspirations to the creation of swarm intelligence. And like I said here, it's typically inspired by bed flocking, fish schooling, ants foraging, and they are used for a wide range of things. They're used for training networks, they're used for routing problems, for load balancing, for network design. This category of algorithms have actually been so helpful in a wide range of industries. And examples include the particle swarm optimization algorithm, ant colony, the bee colony, the firefly algorithm, and also the bat algorithm. If you look through these examples carefully, you would see that they're actually powered by um, animal species, the ants, the bees, the bats, the firefly, a whole lot are actually powered by all those seemingly little, species in nature, but then they have some form of intelligence that we have now kind of brought in and adopted in our AI algorithms. We also have what we call predator algorithms, and this usually are inspired by social hierarchy or hunting behavior of animals. These animal species in this category are usually the higher end animals who uh, feed on lower animals, and so that the predator part of their predator characteristics of these animals have actually inspired this set of algorithms. We have the likes of the gray wolves. We have also the whale, right? Are also part of the species that have inspired the predator algorithms. And usually these algorithms are used for feature selection, right? And for design optimization. It leverages the predator instinct of the animals. And the predator instinct actually helps feature or helps select a best solution, right? Or a best resource out of a wide range of available options. Yeah, then we have also what we call hybrid algorithms. Hybrid algorithms, just like it's just like the name implies, it's usually a combination of one or two or more algorithms. So evolution algorithm can be combined with a predator algorithm. A predator algorithm can be combined with swarm intelligence, and then you can actually see a whole new you can see all new algorithms come up, which are a combination of each of this, two or more of these algorithms. And I just listed a couple of them here. And what most of them, what they are used for, what these hybrid algorithms are used for, they are used to create superior algorithms that, have enhanced features and enhanced capabilities and produce better results, right? Better results even beyond the regular algorithms I shared in the previous slides. So if you look through this, you would see that inherent in nature are some inherent in our AI as we know it today are nature inspired features and nature inspired functions, characteristics. And so a thought came to me that okay, so we've seen a couple of algorithms that are inspired by nature that we see today. What are the possible algorithms we can that can come up? They might not be existing at the moment, but they are possible algorithms that could come up. We have and I've listed some of them here. Pigeon urban navigation protocol. Today we see pigeons line up the streets are urban streets, and they are so good at they actually navigate the urban streets so well, and till you get so close to them, most times they don't even move, they don't budge till you come so close to them. And so that's like, there's a particular confidence they have, and which I feel it's something that can actually be ported into our AI algorithms and our AI solutions. We also have some of like I said, these are some of the things that I'd come up with. There are possible areas that that could come up in the nearest future. Slot efficiency scheduling algorithm. We all know the slot is a very slow animal, minimal, has is able to function not optimally, no rush, no stress, just simple steady movement, and eventually gets whatever it needs to get done. It gets done. And so that could be one of the things that we could actually adopt in our algorithms that power AI solutions, right? Another thing I thought of is octopus snake attack category strategy, rather attack strategy. Octopus today has multiple lanes and is able to do multiple things at the same time. So it's a possible idea that can inspire an AI algorithm where multiple things are can be done, right, with the same resources, with the same resources and servers or nodes, right? And then you can get more done at the same time. Cat induced chaotic algorithm, where today we see cats are in the homes are so they walk around with confidence. They are able to just knock off things whenever they want, however they want it, and they don't at no for no reason they create chaos, right? So it's possible that we also have AI algorithms that are able to just introduce some chaos into a settled territory, right? Introduce chaos and then bring out a solution out of that. And then the last one I thought of is the mosquito avoidance pathfinding. We all know that mosquitoes are a no-go area for us, right? And so there is a technique which everyone it's by instinct. You would rather avoid a mosquito than allow it to just suck whatever it wants to suck at that point in time. So these are some possible directions. Again, they are laced with nature. They are based on nature, and they are They are inspired. They are inspirations that could actually, be adopted for future AI algorithms. So the last point I want to leave us with is, when conventional logic fails, actually, you can let evolution, swarm, and predators actually show the way. They can actually help navigate you out of whatever it is that your AI conventional algorithm is not able to um, provide. So thank you for your time. I believe you have learned one or two things from this session. Thanks a lot.
Thank you, Bis. Thank you. Very insightful about how nature and AI can relate together as well. Next up, we have Amma with From Workflow to Workforce, the Human Side of AI and Automation. Over to you, Amma.
Thank you. Let me just share my screen. Cool. So, hey everyone, I'm Amma. I'm a solutions consultant currently working at ServiceNow, and I have a background in helping organizations align technology with different business consultants and different outcomes as well. So I specialize specifically in identifying those pain points, designing those scalable solutions as well, and translating those complex capabilities. So for example, like AI and automation, which we'll be touching on today, and we push those into sort of real world value. So today specifically, I wanted to talk about that human side of AI and automation. So we often focus on the technology, but I guess this is a real story about people, about work, and also about change. So specifically at ServiceNow, I work on transforming how enterprise workflows operate. So especially using that kind of automation to make things smoother, to make them faster and to make them quicker as well. So whilst AI and automation aren't necessarily new, the pace at which they're changing how we work is advancing and super quickly as well. So I guess it's no longer about just those isolated improvements. It's about that systemic change as well. So we kind of think of it as touching every single team. So when we come to what is automation really doing, let's clarify what we actually mean by automation. So first of all, we've got task automation. So task automation kind of handles those repetitive actions like routing IT tickets, password resets, things like that. And then we've also got cognitive automation. So cognitive automation starts to simulate that decision making, so triaging those tickets based on maybe priority or responding to HR inquiries contextually as well. So at ServiceNow, we use both. So think about maybe chatbots or virtual agents that resolve HR requests without any of that human touch, or think about those intelligent systems that kind of sort through those incidents for the ITTs themselves. So again, AI is not just that tech, it is a strategy. So it's becoming a strategic lever. So it's not necessarily just a tool. So one of the biggest shifts that I saw personally is that AI is not just that technical layer. So companies are gaining the most value. The ones that are those that embed that AI into their business logic. So it's not necessarily just that kind of plug in and play. It's about redesigning their entire workflow with AI at the center. And then when we come on to the human element, AI reshapes those roles. So it amplifies the human capability, but I guess it also causes some friction. So there's a persistent fear that AI is going to come and it's going to replace the people and all of the agents. But again, that's not necessarily what we're seeing within our workforce. So yes, AI does change a lot of roles, but more often it actually amplifies the human capability. So, for example, freeing up people from those repetitive tasks like those password resets or those email issues so they can focus on that more strategic work. So instead of putting out the fire, they're being a lot more proactive. So still, this shift can maybe cause real friction, a lot of fear, and also resistance, and even sometimes burnout from what we've seen. However, we've taken a few lessons from there. So at my time at ServiceNow, we saw a lot of real wins. So for example, incident resolution got faster. When we think of incidents, we mean sort of tickets that kind of go through, sort of unplanned changes, really simple services that end users can kind of push through and get resolved. So those services became so much more proactive and a lot more less reactive. And all the different employees that we kind of spoke to spent a lot less time on those sort of routine tasks. But again, you kind of wonder what was the hardest part? It's not necessarily the tech, it was the change management. So training, building trust in those AI outputs, and then aligning those people around a new way of working. It really took time and it took intention and also a lot of trust. So when we kind of are forward facing and looking ahead, the rise of that Gen AI is pushing automation even further. So into content creation, decision support, and also different personalized user experience as well. But again, this kind of raises some new questions. How do we stay ethical? How do we ensure that transparency? And how do we kind of prepare the workforce? So not just technically, but emotionally and culturally as well. And from that, we kind of had some key takeaways. And I guess to sum it up, AI is a tool. So it's not necessarily just a magic bullet that's going to solve all the problems that you have. We kind of have to work with it and mold it to exactly what you want to see with the outputs. People. So people remain central to every single transformation. So as we said before, sometimes when you kind of come in with a really new idea, some people are fearful, some people might resist it. But again, keeping people in your intentions is always the way forward. And then change as well. I guess to succeed, we really need to invest just as much in culture and change as we do into the code. So just to kind of close out, I'll leave you with this. What does responsible automation look like in your own organization? So it's not just about what we can automate, it's about what we should. So thank you so much for listening, guys. I'd love to continue the conversation. Feel free to reach out with me on LinkedIn.
Thank you very much. I'm definitely one who's been guilty of automating everything. I think that thinking about what we actually should be doing is the right thing as well. Really insightful talk. Thank you very much, Amma.
No worries.
Next up, we have Antoinette. Are you there, Antoinette?
Yes, I am. Hi.
Fantastic. So we have Antoinette with what's really going on behind ChatGPT's answers. Over to you.
Hi, everyone. I'm Antoinette Adeyin. So, can you see my screen?
Yes, we can.
Okay. So today I'll be going through what's really going on with the ChatGPT answers. So the first thing is, we know ChatGPT, it's not sentient. That means it doesn't really have knowledge of its own. So it basically mimics languages that we put into it. It mimics whatever it is that we give to it. It's just like we say about computers, it's usually garbage in and garbage out. It predicts the next word based on the vast number of training data that is received. And then this basically built on transformer architecture optimized for large language tasks. So let's stop speaking all this big grammar and try to break down what's happening. So when you come up with a question that you want to ask ChatGPT, say you, for example, here we have, why is the sky blue? The first thing it does is to break this question into chunks of data. So it kind of breaks it into chunks that it understands, because computer doesn't understand the alphabets. It works more with numbers, with vectors. So after breaking this into chunks, it then converts it into vectors. And from vectors, then it goes into the transformer system before it gives you your answer. So in giving you your answer, it's predicting the most likely word that would go with what you've just asked based on the number of data that is being given. Now, previously, in the previous GPT models, now we have GPT 4.5. Gemini just released Gemini 2.5 Pro sometime this month, and that's AI on reels, I must say. But typically what we had before was probably most of these large words, like say we have a word like plane, can be broken down into two, because the system would take it that plane is a very large chunk of word, so it breaks it into two. And that was one of the main reasons that was leading to so many levels of hallucination. But with these new models that we have, those words are actually taking how they are. That's why you see that most models right now are more correct than what we used to have before. There's like a real reduction in the hallucination. Then the next thing is, how does he learn? Sorry. I don't know. Just a minute, please. How does ChatGPT learn and then learn better? So it learns using reinforcement learning through human feedback. So you find out that whenever you feed ChatGPT it's already been fed with massive loads of data. But whenever you feed a query to it and it maybe gives you a wrong answer, and you reprompt it, or you try to correct it, or try to train it and teach it, it learns, and it's eventually, after several prompting, you see that it goes back to give you the right answer that you're looking for. So that's what we call human feedback reinforcement learning. So you're kind of rewarding it for giving you a right answer. Every time it gives you a right answer, you're kind of rewarding it somehow. And that's the reason why it goes back to keep on searching till you get to that point where you're happy with the answer. that you're looking for. The next bit, sorry. So what makes ChatGPT work so well? So the first bit is highly fluent generation. So it sounds really natural and human-like to some extent, depending on how you prompt it. Most people complain about it because they are not prompting the way that they are. Prompt engineering on its own is a course, is an occupation that most people don't understand, because you need to understand how to prompt the system for you to get the best out of it. The second thing that makes it work so well is the broad knowledge. It's actually trained on vast number of data, and is also being trained and retrained on a daily basis based on what we're feeding it. The third reason is it is multilingual. It's multilingual reasoning, so you can actually tell ChatGPT to give you your answer in Pidgin or give you your answer in Swahili, and it's going to go ahead and do that. So it's been trained on those level of data that could actually give responses whichever way you want it. And it's also aware of context to some extent, also depending on how you prompt it in this day and time. Before, we used to hear that ChatGPT knowledge was cut off in 2020, but it's not so anymore, because you can actually tell it to go into the web, search what you need, what the answer you want, and return it back to you how you want it. The next one is why ChatGPT sometimes sounds wrong, sounds right but is wrong, and I've explained some part of that. The reason for that is hallucination. Probably if one of the causes is wrong prompting, you didn't prompt it the way you're supposed to. The ideal way of prompting ChatGPT, if I'll say that, is you making it live in that context. Like if you want to solve a problem, say an analytical problem, and you want it to be able to assist you in that problem, the first thing that you want to do is to make it be in that context. That you have to start with something like, you are an analyst or you're a senior level analyst. That's something, that way it's aware of the context, aware of the kind of result. Otherwise, if you don't give it a context, it goes broad. And that way it's giving you a wrong answer with confidence that is right. So this happens because it has no access to real facts. There are gaps in the training data. Sometimes it doesn't have yesterday I prompted it to ask about my husband, and he gave me another person's picture. So that's because he doesn't have any data. My husband is not an internet person, so because he doesn't have any data online, there was no way for GPT to get any data on him. So that's one of the problems. You cannot. It can only give you as much as it has. And the next one is ambiguous or contradictory prompts, which I've also spoken about. If you give it the wrong prompt, or you make the prompt so broad or so ambiguous, it will also give you a very broad response, which may not be what you want. So the model doesn't know what it doesn't know. All the onus is on you to make sure you're prompting it right and you're leading it right to where you want it to be, or where you want to get the right result out of it. So the next part is transparency and the reliability of AI. So some of the principles, I've listed some principles here that helps it remain transparent. The first one is a regular update based on user feedback and human review to improve the accuracy. So they are constantly training. Previously, if you ask ChatGPT a question like, what is mass? It would give you a wrong answer. But if you do that right now, you find out that it will actually tell you that what is the capital of mass? I mean, it will tell you that there is no capital of mass, but based on some series of movies, this is what we think can be, or this is what the movies assume to be the capital of mass. So the hallucination to some extent has reduced, but it's still there though. Clear communication, to you explain what the model can and can't do and where it might go wrong. Responsible use, we need to make sure that we're using it responsibly. We need to make sure that we're not creating bias, we're not making it used to some gender or some race, or creating bias for the other race. We should also empower users, teach people how to question it, cross-check that is right. I always tell people I work with in the office that just because ChatGPT gave you the code does not mean the code is right. And just because the code ran does not mean also that the code is right. You have to make sure that you go back and you check. That's where the context, I like what the last speaker said, that people are all afraid that and thinking that ChatGPT will take over our jobs. But I'm also part of the people that don't think so. I think right now that people that will go far in most of these careers are people that are able to put human thinking to whatever it is that machine is doing. Now you're looking at positions like mine. I'm an analyst. We're no longer going, because any tool can write your SQL code, can write your R code, Python, whatever you want. But now those tools can't tell you business context. They cannot tell you the reason why those, they can only guess. But then I have domain knowledge of so many things that would help me make the right decision for my organization and not guess it. So that the people that will stand out in the future are people that are able to actually ask the right question, have the domain knowledge about things, and know how to follow through using these tools to empower them. And the next one is RAG. Before last year, RAG was all over the place. It was just you feeding with more information, like as I asked the question about my husband and he didn't have an answer, what I can do is maybe give it a PDF file of my husband. It goes ahead to vectorize that and tokenize it, and then he has the right answer. Whenever I ask him that question, or when I ask him that question the next time, he's able to give me the right answer. You can do this using Pinecone as your data warehouse, whichever way you want. You can use AWS, whatever, to just build a retrieval augmented generation system that can help you retrieve information that GPT doesn't have to make it better and serve you better. But right now, what is reigning, what's all over the place is agentic AI. We've moved past the RAG stage. RAG is still there though, but now we're all about the agentic AI. So you're equipping the AI agents with goals and memory and reasoning to act more transparently and more adaptively to whatever it is that you need. So you're training it on one particular domain and making it be a guru on that domain. So whatever it is that you're asking it is able to answer you based on that domain. That's the level that we are now with agentic AI. So in conclusion, I'll just say that ChatGPT is powerful, but it's not magic. The better we understand it, the better we're able to use it. We should also remember that it has limits. We should know how to prompt it, because I know that there are some guardrails in place now to make it, if you ask questions that are contrary, or maybe you just want to ask questions that are not what you should ask, maybe asking about some drugs or something, it should just give you an answer that you're not meant to know that, or it will give you a contact of a helpline or something like that. That's what it does now. But then we should also know that it has limits, and we should build trust. And lastly, transparency, ethics, and education to unlock safe and effective use of AI. This is just a brief description. If you want to know more, there's a lot on the slide, but I'm just trying to stick with the 10 minutes because there's a lot that goes on. But if you want to know more, just hit me up on LinkedIn, and I'll be willing to share anytime. Thank you.
Thank you very much. And again, you're the second person now after Amma to say that ChatGPT is not magic. So thank you for clarifying that again as well. Take the talk, and I know again people found that really, really valuable. So the next up we have Rianat. Rianat, are you there? I've made you a co-host. You should be able to share, hopefully. Fantastic. Okay, over to you for Zero Trust AI, securing the future of intelligent systems.
Okay, thank you so much. Let me try to share my screen.
Okay.
Okay.
Perfect.
Yeah. Thank you. Hi everyone. I'm really glad to be here today. My name is Rianat Tabas, and just to give a bit of introduction about me. I work as a product security manager at AI4i, but my work prior to that, I have background in product development and cybersecurity, and I focus on how we build and scale intelligent systems that are not only powerful, but they are also safe and accountable, as well as secure for us to use. So today I will be talking about a concept that is becoming more critical as AI becomes part of our everyday lives and things that we use every day in terms of decisions, infrastructure, which is Zero Trust AI. Just to start with a little bit of like a background, in cybersecurity, like Zero Trust is a major concept, and it has long been a standard in cybersecurity. It is designed to protect against threats by assuming that nothing inside or outside a system should be automatically trusted. So that is what Zero Trust is. Whether it is inside a system, whether it is outside a system, you shouldn't automatically trust it. So right now we are at a point where this same principle needs to be applied to artificial intelligence as well, because these systems are not only running in the background anymore. We are now using them to shape like access, just like the way we use it every day, right? We feed any LLMs like ChatGPT, Gemini with any information I want to feed it with. And the way they are shaping the outcomes and experiences across different industries, there is also a need to apply the same zero trust principles, like whether it is inside, whether we are the one that built it or we integrated it as a third-party system, they are not meant to be trusted. So the first thing I would probably like, why zero trust AI? Then why now? That is more of like the question that comes to mind. And we are at a turning point where artificial intelligence is not just an internal tool, like we are now using it to make critical decisions. And most of our current AI development still runs on, an assumption of trust. If we ask people that are using AI, they will be like, oh yeah, we trust the system, or whether they are using it internally or they are building it for like external use. We are currently running on an assumption of trust. And trust in the data, just like the data that AI is being trained on, because artificial intelligence is being trained on data. And so the trust that is in the data, that yeah, we trust the data, we trust the outputs of the data, and we also trust in how the models are being used across the team. So we don't probably like necessarily have to fact check how are they using this AI that we embed into the system. Are we is there an ethical guidelines on how to use it? Are we auditing it on how we are supposed to audit it? So the zero trust model currently challenges that assumption, challenges the trust that we embed in the current use of artificial intelligence. And it has caused like to slow down. What zero trust AI means is, let's slow down and look closer into the system that we are building, into the system that we are integrating, at who have access to this, who are the people that have access, what data is being used to train this particular data, and how are the models being behaved, and where things could actually go wrong. Having to ask or second guess all those things and all those questions help us build a principle of zero trust. So this is the right time where we have to embed that, because AI is scaling at a rapid rate, and we are not even like, we can't catch up at the extent to which the model or the system is scaling. So this matters because the risk currently have scaled. The risk when it comes to AI have scaled, and we are looking at risk regarding shadow AI. There are a whole lot of risk around artificial intelligence right now. When it comes to bias, when it comes to shadow AI, different things are coming up, and hallucinations, name it. So currently right now, we need to like at the crossroad of embedding the zero trust AI into it. So if we look at zero trust in its entirety is built on a few key principles. And we look at it as, the first one is never trust, always verify, which means every action must be authenticated and also authorized with no exemptions. So before you give someone access, before you feed that LLM or that model with documents, with critical documents, with intellectual properties, like critical things, or use it to make decisions, you need to authenticate it. Can we really trust this? So this kind of frameworks help us to guide the way we use and build artificial intelligence. And secondly is assume breach, right? Systems are designed with the expectation that something could go wrong. Even beyond artificial intelligence, before AI becomes a thing, the normal softwares that we build is being built with the expectation that something could go wrong, like whether either insider threats or someone from the outside wants to infiltrate the system. So controls are built around this containment and detection that, let's assume that there will be breach. We are not saying there will be, but we can make an assumption. So the way we build it will be around this. And the last one is least privilege access. In cybersecurity, we have something called least privilege access, which is giving users, application systems only get the minimum access that they need to do their work and nothing more. So if we are using an artificial intelligence, or we are building it, whether integrating it as a third party or building our own, we also need to ensure that we incorporate least privilege access, because these principles were originally built for network security. But right now that we are in the era of AI, we also need to apply the same thing, the same principle to artificial intelligence systems, because they are being robust. They are robust even more than the way we can envisage. So there is also a need for us to have a guiding principles that would help us to shape how we use and embed it into our systems. And there are, like I mentioned earlier, there are different risks currently associated with artificial intelligence. And traditional softwares allow us to define rules in terms of, who should have access to what? Can it be tested? Who is writing what? So that is for traditional software. AI systems are different because AI learns on patterns. They learn patterns from data. They are being trained on data, not like we built them originally. We feed and train them based on data. So we have to adapt them over time. We have to ensure that they behave the way they are meant to behave over time. So there are different risks that is associated with AI systems. And one of the things that I have here is data poisoning. A model can be compromised at its core if even a portion of that training data is manipulated, which is something that is getting like frequent right now. Like, because we know that artificial intelligence is being trained on data, one of the unique risks that come with this is data poisoning. How are we going to ensure that the data that we are training the model on is not being poisoned, is not being manipulated? And the second one is like model inversion, right? Sensitive data can be reconstructed by a deployed model, and attackers extract training data from also like exposed model. There are different open source AI systems right now that people are using. And the fact that we are now integrating all these open source AI model into internal systems, into critical parts of the system, and also feeding in with sensitive data, we are exposing not only ourselves, but the company to risk, to adverse risk. So the model inversion sort of like is one of the ways that AI systems is being exposed to risk, and most especially with open source AI systems. And shadow AI, which is like one of the frequent one, like the story of Samsung, how it happened at Samsung company some years ago. So teams sometimes experiment with AI tools outside approved systems, and that is where shadow AI comes in. Employees use like different unvetted AI. If I probably like ask us, like, when was do we get approval from our companies before we feed any LLM with documents? Probably be a no. So shadow AI is now rampant, and the way we feed all those LLM models with like sensitive data, critical information, is also like another unique risk that comes with like AI systems. Now, beyond just like the whole AI risk and zero trust, there is also an AI lifecycle. And how can we actually apply zero trust to the AI lifecycle? So for us to be able to apply zero trust to AI, we need to look beyond just the infrastructure, because AI is not just the infrastructure, and we also need to embed it directly into the AI development and deployment process. And the first stage of the AI lifecycle of applying zero trust to the AI lifecycle is data trustworthiness. I see this as the first steps. Like, every data set used to train a model should be vetted like a software dependency. Like, can we trust this data? All the parameters of the data, what are the things that are embedded in it? Where does the data come from? How is it being labeled? Like, what are the risks that it might carry? So at this stage, we need to ensure that the data is trustworthy. That is one of the first principles. And the second one is model access controls. Like, models need the same security standards as critical systems. So this includes like multi-factor authentication, access logs, role-based permissions, right? We should identify every person's role when it comes to the AI development and give them the right access, that the minimum access that they deserve. And another one is inference integrity, right? What goes into and comes out of a model should be controlled. We shouldn't just like leave it open just for us to prevent abuse, like prompt injection or even like the output manipulation. And the fourth one is the continuous evaluation. Just because we built something and we are so confident in the data that we feed it with, doesn't mean that we shouldn't continue to evaluate it. AI systems are not static. The data that we train it with are not static. They keep evolving. So there is a need to monitor them over time for just for any emergent bias or any signs of like abnormal behavior. So there should be like a continuous evaluation. And the last one is the governance and the explainability. Every team, this is a cross-functional team. Applying zero trust is a cross-functional team, and teams should be able to explain what a model is doing, irrespective of whether they are technical or non-technical, why it's made that decision, and who approved the changes. So there should be governance around the AI lifecycle. We should know who is responsible for what, who approved this data, who approved us moving from this state to another. So there should be a governance in place for us to be able to say, oh yes, we want to embed zero trust AI approach. So that is like the overarching of how to apply zero trust to the AI lifecycle. And just to give like a little bit of context into one of the risks of the zero trust, like one of the risks of AI that is, imagine, I mentioned Samsung ChatGPT leak the other time, and I put this slide for us to understand the risk that comes with us using LLM every day, whether approved or unapproved, and also whether it is for business or also personal use. There is a recent example that caught global attention some years ago, which involved Samsung engineers, software engineers, who used ChatGPT to help troubleshoot internal code. Now, the fact that the engineer used ChatGPT to troubleshoot internal code doesn't mean that it is bad, but it also means that there was no governance in place to actually fact check whether they are meant to do this. So while trying to troubleshoot internal code, unknowingly, they shared proprietary source code with a third-party system. And this means Samsung doesn't have control over ChatGPT because it's a third-party system. And this engineer that fed the ChatGPT with proprietary documents or source code doesn't also have a control. So these particular incidents, if a big company like Samsung is prone to this kind of risk, it shows that even smaller companies, irrespective of where we work, whether we work for a smart startups or a big company, no company is immune to AI risk. And this is exactly where zero trust comes in. And this particular area of Samsung ChatGPT leak comes in at the part of the governance. Did anyone actually give permission for these engineers to use this particular tool? And what was the guiding principle that should have been done before they use it? And so as we sort of like round this up, making zero trust AI a daily practice is one concept that I like to also like talk about. It is a collaborative effort. Zero trust is not only for the security or the engineers. We also need to know the role that we play in each of the life cycle when we are talking about zero trust. And we have the security teams. Because it is a collaborative effort, we have the security teams which should extend the threats modeling into the AI systems, looking at the data flows. They should look at like the model exposure. What is the point of failure of this particular artificial intelligence? And also for the product teams, which are the people that are coming up with the requirements, people that are coming up with the strategies. They also need to treat explainability as a feature, right? Not just something that will be an add-on to any AI development. So if a model can't really justify its outputs, then they are not actually ready to ship it. So if you are a product manager, a product owner, whatever role you have, there's also a need for you to understand zero trust and know the role that you play when it comes to AI development. And also this is applicable to developers. Who are the people that are actually shipping, the data engineers, the developers that are actually shipping this? They should also like, there's a need to look at the APIs, like properly look at the authentication, the usage controls, monitoring for abuse, or even prompt manipulation. So understanding all the segments will also help us to make zero trust a daily practice. So as we are building, we are also incorporating all those things. And lastly is the leadership. Leadership also has a role. Like I said, the zero trust principle is not only for the technical, it's also for the non-technical. If the leadership can get the buy-in for zero trust, then there is also going to be like a good governance. So there is a need for leadership to start prioritizing AI governance as part of product delivery, right? Have we done this? It shouldn't be separate. It shouldn't be reactive. It should be proactive rather than being reactive. They shouldn't wait till something go wrong before they can actually address it. Rather embed it into the product development lifecycle, which is from the discovery phase to the post-launch activity. What does this actually tell us in a greater on an eye level? As we sort of like look at everything from principles to how should you, which role or what role do we actually play in zero trust AI, there is a need for us to know that AI expands the attack surface and we should treat it as such, right? AI brings new risk into the system beyond just the traditional software. And we need to start thinking about those risks and threats. And secondly, is trust boundaries must be redefined, especially for intelligence systems, not only the traditional systems. We need to start looking and interact across teams, across tools, across environments, look at who have access to what. And also zero trust should be aligned with like security, compliance, and product team. It's a cross-functional responsibility, not only for the security or the compliance. And finally, building with zero trust AI now is not just that we are slowing down the innovation. There have been like a whole lot of discussion around, oh, security for AI can slow down innovation, but rather it prevents what we cannot foresee. And building with zero trust AI today help us to prevent that failures tomorrow, any risk or threats. Not like we can completely avoid risk or threats, but having zero trust AI help us to minimize the level of risk or exposure that we have when it comes to artificial intelligence. So those are just like the final takeaways. I don't know if there are like questions or anything I need to like address before. So thank you everyone for listening. You can connect with me on LinkedIn if you have any questions that you feel like you want me to answer, and I'll be so happy to address them.
Thank you so much. And I guess that's the key thing that you were saying really is like, it's important that everybody considers like, you know, the security and the safety with AI throughout the whole team. And I think individuals as well, because I know that people are definitely using it in ways that they probably shouldn't be sometimes when I look at how
Yeah, we need to start asking ourselves before we feed them that, are we really trusting the system with the information we are feeding it with? Yeah.
Absolutely. Thank you so much. If we do have any questions, I will send them over to you so that we can get them answered after the session. Thank you. Okay, next up we have Omar with containers explained with lunchboxes.
Hi everyone, good evening. I'm Omar. I'm gonna bring up my slide deck in a bit. Can we confirm that we can all see my screen?
Yes, we can, absolutely.
All right, nice. So I'm Omar, DevOps platform engineer, currently working at MTN. Been at this for a while and I love what I do. In my free time, I give back to the society or community by teaching tech to kids in underprivileged societies along with my friends. So to start off with today's class, we're talking about containers. We have on the screen lunch boxes. So the one on the left, I mean, there's food everywhere, but the one on the right is nicely packed. And this is just how code is. So in a team of developers, you have people working on different projects. Some people work on front end, some work on back end, some work on other things. So everyone's code is kind of like all over the place. And when you want to deploy it, that poses an issue in the sense that you're not the one who writes the code. Your job is to deploy. And even if you communicate to the developers, sometimes you still need their guidance in order to properly deploy their code. And this is where containers come in. So containers will help you to like stack up the codes nicely and neatly so that when you deploy, you don't get like any collision or face any major issues in production. So there's this thing called a dependency hell, and it's also the scenario of a developer saying, well, it works on my local system. Why is it not working on the server? And container comes in the sense that, so I, as a DevOps engineer, my job is to ensure that both the front end, the back end databases, and other like sections of the code communicate nicely with each other, and they're able to like support the websites. And so how do I go about this whole process of building a container? So the first thing is to properly package applications. So all applications, like individual applications built in whatever languages, properly package everything with their dependencies. Then the next thing is to label them. And then the next thing is to ship them properly to probably like a container registry. And then lastly, I run my launchbox or container, for lack of a better word. So I'm gonna show a code ideally, and I want everyone to confirm that they can view what is on my screen. Okay, I take the silence as a yes. So this is me learning about fast APIs, and I have written instructions on how to get the app running locally on your machine, and also a guide on how to containerize the application. So I'm just going to show us my terminals. So my terminal is just like showing output of commands that I have run. So this is me starting the app locally. Now this is me containerizing and running the application. You can see that I built it and then I ran the application. And this is how a Docker file looks like. So a Docker file is basically the configuration file you write up that helps you package your application nicely. And this is using a Python image because it's a Python application. And so normally I can run these steps like manually, like one by one. But now, because I'm putting it in a configuration file, it has to be together using certain keywords. And this packages my application. And then this is the command to run my application. And we can see like an example outputs attached as an image here. So the next thing is to push my image or container to a container registry. When you think of container registries, you can think of something like your GitHub, where you store your code. Container registries like Docker Hub, where I store my containers. Anybody like all over the world can access those images as long as it's public. And if you want to make it private, maybe it's like your official work stuff you're working on, you can put it in a private registry where it will be accessible to only specific members of your team. So these are the commands you run to push your app to a container registry. The reason why you may want to push your app to a container registry is just to like keep track, something called version control. So you can push a version 1, version 2, version 3, and so on. Now, to also test if you properly pushed your application properly, you can pull and then run your container image. So that's what I did here. So I pushed here, and here I pulled and I ran my container. So okay, so that's that. And so all what I just spoke about now is what's on my screen. And you can find code samples at this GitHub repository. It's a public repository. Anyone can go there, pull the code, test it, do whatever thing you want to do. And yep, thank you very much for your time. So this is my LinkedIn. You can send me a text if you want to, I don't know, catch up, learn more or whatever. And I'm going to attach a link in the chat so everyone has access to the slide decks. And yeah, back to you, Charlene. Thank you so much.
Incredible, thank you. And I think that breaking down containers as a container is such a good idea that I think a lot of people don't do. Very much for that, made it really, really clear as well. Okay, next up we have Dorothy, who will be giving us understanding credit in collaborative projects. Are you there, Dorothy?
Hi, Charlene. Yes, I'm around.
Fantastic. Over to you.
Okay, I hope everyone can see me and all that. Yeah, so let me share my screen. Okay, so just confirm with me if you can see my screen on your end.
Yes, we can see your screen and we can see you as well. Over to you.
Okay, thank you. So I hope everyone is doing well, and I'm also good on my end. Yeah, so today I'm going to talk about credit. I hope maybe some of you have heard of what credit is. It's kind of just giving ownership or authorship to maybe working on a certain project. Yeah, so before that, even touching on that, so my name is Dorothy Akoth, and I am a software engineer by profession. And I'm also a Coding Black Females ambassador from Kenya. Yeah, so yes, I'm a software engineer at a remote company based in Kenya. Yeah, so my tech stacks are Python, React.js, and Django REST framework for REST APIs. Yeah, so before I go to like explaining what a credit is and all that. So what made me like to come up with this credit topic? I remember this is the story now, like why I started using the credit contributor role taxonomy. So it all started like it was during a major sprint at my company that I'm currently working for. So we had just wrapped up a big collaborative project. And then a feature packed system update involving multiple developers, designers, and also and even documentation team. So my boss always focused on transparency and accountability. So called for a meeting. So he said something simple but also powerful. So I wanted like to see exactly what each person contributed, like I think that was his words. Like I want to see exactly what each person contributed to the project that you are working on. So not just names on a commit log, but real roles. So that's when it hit me, and I thought of the GitHub contribution graphs and commit histories, which are very useful, but they don't tell the full story. Just because someone didn't push 1,000 lines of code doesn't mean that they didn't play a critical role in that project or the project that they were doing. Yeah. So, like, what about the person who conceptualized the feature, who wrote the documentation, who tested and debugged? Yeah. So I was given the task of documenting each contributor's specific role. So I hope when you go to your GitHub, and you are the admin, so you are able like to add some of the roles, like there is a role for maintaining, there is a role for admin, and yeah, we have several roles. Yeah, so I was given that role for the admin so that I can add other roles, like for maintaining maybe the code, the reviewers, and those who can write and those who can review the code, or the project that we've written, right? So and also we can do it either around like in the GitHub where we assign the roles, and also in the README file, like where you can have now the people like contributing to such or to that project. Yeah, but I thought that not I thought, but it was kind of my repo like could have like been very long, like having everyone like contributing there, and each and every time that you push your code, you put your commit to GitHub, like you'll be able like to see it in the README file. So I thought that was not a good idea. So I just decided to go to the GitHub for assigning the roles, the security part, and then assigning the roles. Yeah, actually that is what made me to discuss this topic called credit. So actually, what is like understanding, or what is credit? So I'm going to talk about an overview, some of the overviews, why it matters and how it enhances clarity. That's from the story that I've given you. Yeah. So what is this credit? Yeah, let's see what is this credit. Yeah. So sorry, I'm using two devices. So what is this credit? So credit stands for contributor roles taxonomy. It's a standardized way to describe the specific roles that each individual played in a collaborative project. From my story, where I was like asking like who contributed to this, maybe the commit, who contributed to this role, who debugged this part of the code, yeah, or part of this project. Yeah, so actually this is what credit mean, and that's its meaning. Yeah. And in my next slide, like why is it matters, or what's some of its benefit? Yeah. So from my story, my boss like wanted to see like kind of transparency, like who contributed to this, and what kind of commits did this person committed to GitHub? Yeah, or what kind of commit messages this person pushed to GitHub. Yeah, and also fairness, like when I talked of fairness, like everyone gets credit for their actual contributions. Like we can't say that we only like see the seniors like that, the ones working, but we are leaving the juniors behind. Like they're not doing anything on the project or pushing anything. So we also have to consider the juniors, and that is why I came up with the credit. Like I want to see like everyone contributing to a certain project. Yeah, it also aids in collaboration. So it helps team understand and value all types of contributions, not just coding or leading. Yeah. So yeah, when it comes to aids collaboration, like we can have maybe testers, we can have UX designers, like we want to see for the front-end people, for the front-end team, what did they do? Like we want to see that person who pushed, maybe he or she changed some of the UIs and all that. We want like to see what did you change in your front-end or in your UI? Yeah, so that is why credit matters. Yeah, it also supports career growth, where it clarifies and highlights contribution in team projects, especially for underrepresented roles. Yeah, I think that is well explained. Yeah, and yeah, we have the 14 roles. So I just find out. Okay, I listed like 9, and I'll share I will share the documentation maybe after the presentation, so that maybe you can go through all of them and then you understand. There are 14, but I decided to list 9 because of my small slide, yeah. So I will work on them, and then I will share the documentation so that you can maybe go through them and see like what each one of them does. Yeah. So yeah, so these are the roles for the credit taxonomy, in the credit taxonomy. Yeah. So in implementing credit in your team, you have to introduce credit during kickoff. So this one during kickoff, like during meetings, yeah, not only in big meetings, but maybe you guys have, maybe you've heard of stand-up meetings during, maybe you want to like showcase like whatever that you've done during the week, whatever that you are going to do during the week. So we always start like each sprint or project by explaining the credit taxonomy to the team. Then we emphasize the 15 contributor roles, especially those relevant to software, like yes, maybe you are in a software team, or maybe in your QA engineers, you're a tester, you are researchers, and all that. Yeah, so, and then what I came to realize that when working with the credit, it's mostly it is in the research. Like you want to see like who did this research, like who is this authorship and all that. Maybe if you go to Wikimedia, is it Wikipedia? Yeah. And you just browse through any documentation in Wikipedia, and you just browse through, and you'll be able like to see like people who have contributed to a certain research that they have done. Yeah, so that is actually that is what credit is all about, and it will kind of, you'll understand it better. Yeah, and also it maps contributors' roles. It use a shared spreadsheet or task board to match team members to credit roles. Yeah, so an example that is, now we can have name, role, and then the task. So the role there, it's kind of role can be QA engineer, can be software engineer, can be researchers and all that. Yeah, so you'll be able like to see who did this, and you can always use a shared spreadsheet or a task board to match team members to credit roles. Yeah, also we have you can use shared tools. That is the Google Sheets, the ones that are shareable. Yeah, the Google can I say the internet thing? Yeah, so you can always share like the roles, like you give them the what, you give them just the same way I've explained in the second point, like map contribution to roles. So like that is when you can share like who is going to do this, who is going to who is doing this, who is going to do this in that day and all that, who's going to contribute to this and this kind of project. Yeah, actually, so that is what it explains. Yeah, and also in GitHub, the way I did it, I explained it earlier that yeah, in GitHub we can also have we can like have credit thing, yeah, where you can see like who pushed this commit, like, or who worked on this I and all that, yeah, for the front end. Yeah. So in my next slide, this is just a use case example. Yeah, so I was explaining about like having like all the roles, the credit taxonomy in your README file. Yeah, so I said that, not I said, but I'm saying that having them on the README file can be kind of, it can occupy all the README, like each and every time that you push your code, they always appear. Maybe you can try it out on your own for maybe just try it with a friend, kind of, you are working on a certain project, like you've come up with a certain project and maybe you want to contribute. And when you go on and maybe write this part here in your README file and you push it to GitHub each and every time, you like be able to see the person, like you'll be able to see each and every time that you pushed your code to GitHub in the README file, you'll be able like to see who contributed to this and this, leave alone the commit part where you will be like you'll see my face and my name, like my name for the GitHub. But this one here, you see the way it is written here, that is what you're going to see now in the README file. Yeah. Oh, I wish I could have demo, though I only have my company project, but it's recommendable to do that is now with the practical. Yeah, I wish I could. Yeah, so actually you can try it out with your friend and just write this maybe this part, and you'll be able, when committing it each and every time, you'll be seeing like your name and the role under the README file. Yeah. So that is it. And in the conclusion takeaways, so credit helps teams function more transparently and equitably. It also recognizes like all voices in collaborative tech work. That is like we need to know like who did this, who committed this. Yeah, like we need to see everyone contributing to a certain project, not leaving anyone behind. Like now you are a senior, so juniors are not supposed like to push their code, or the mid software developers are not supposed to do this and this. Like we want to see each one's project in like each one commit or each one a contribution to a GitHub or in any research work that you are doing. Yeah. Also try using credit in your next project kickoff. Yeah. Try it out. You can play with the README file if you don't have an admin role in your GitHub. Yeah. Or maybe if you're a researcher, it's not only for the software developers who are coding, and it can also be anyone, like maybe you're a data analyst, maybe you're a data scientist, maybe you are doing what? Yeah, you can always try it out. Yeah. And also, yeah, so, and even in the, maybe in the Google Sheets, the Google Doc, you can see who contributed to this. Like you can see, like you can monitor who is doing this and who is doing that. Yeah, that's also part of the credit. Yeah. So so that is it. And any question that you may have, I'm always on my LinkedIn. My name is Dorothy Akoth. You can search me and ask me more about it, more about credit. And thank you all for listening. And I'm happy to be here to share this credit thing with you all. Thank you.
Thank you, Dorothy. That was really useful and insightful. And I think it's always good to hear about anything that will make the way we develop software fairer, and especially fairer for the people on the teams as well. So thank you very, very much. Next up, we have Fola, who is going to be covering behavioral biometrics, fighting fraud without friction. Over to you.
Thank you. Should be able to share my screen now. So bear with me, should be the slideshow.
Yeah.
Can you see? Yeah.
You can see it. Fantastic.
Yeah. So hi everyone. So my name is Fola, and I'm a data scientist based here in the UK. So currently I work for Synetic Solutions. So we are a solution company. So we help financial institution, where we help insurance company to track fraud and to identify fraud from their client. So today I'm going to be talking to you about using behavioral biometrics to fight fraud without friction. So I know just the word fraud, if I just ask anyone here, what do you know about fraud? If you are not the one, if you haven't experienced fraud before, I know you would know someone, possibly a friend, a family member, or someone who has experienced fraud before. So it is something everywhere. I mean, no matter in the location you are, it is something everyone experience globally. And this fraudster are just keep adapting to new strategies. So this is something we should look into and get inside how we could fight fraud the best way as possible. So today I will be checking some key points using behavioral biometrics to fight fraud without friction. So I'll just jump into it. Yeah, so I just want to share a little bit of my insight about the fraud problem we have today. So looking at some open source, it's found out that we have about over $48 billion in global fraud loss in 2023. And as of 2024, we have a projected $485.6 billion US dollars and global fraud laws. So just like I said earlier, it is something global. It's not something for a particular region or some particular people or for some particular color. It is something everywhere. So I'll just look at some fraud types, the most common ones, just so I don't waste time because there are a whole lot of fraud. So yeah, just the common ones. And today we have the top one, which is the account takeover. This is a situation where someone steals credential of people. For example, let's say a bank account. This is where the fraudster would get the information, the access information, the username, the password, and everything, then take over the person's account finally. So in most fraud cases we have in the world today, we would see that this is it. I mean, out of 3, we would see that this account takeover is 1. So it's something that happens almost all the time. Let's say over 30% of fraud today, it is account takeover. So another one we have is the credential stuffing. This is where fraudsters use AI, chatbots. They use it to generate possible password, trying user's name and the password composed to see if they can access the user's account or probably their valuables. So this is the main reason why you would see that in today's world, if you're trying to open an account where you're trying to sign up or open or log into an account, you'll be required to use a strong password. Do not use something that include your username, your date of birth, and stuff like that. You would always be advised to use something different so your password could be strong. And this is because this fraudster, they keep improving every day as the new solution emerged to counter fraud. The fraudster as well, they try to adapt to this new solution and still make sure that they penetrate. So this is the main reason why most organizations would want you to use some kind of strong password, not something too familiar with your username or with your password. So another one, we have the synthetic identity. This is when the fraudster would gather synthetic, or let's say some kind of fake data, and also some kind of real data. I mean, the one stolen from the real user. Then they kind of fabricate this together to impose or to impersonate the real user. So, and it happens about 20% year over year. So, 20% of fraud, globally. So we also have the payment fraud, where we have stolen cards, fake payment for goods and services, over $12 billion loss in this aspect as well. And lastly, we have the phishing. This is by tricking people. It could be through an email, possibly a phishing email. When you receive a phishing email telling you to do something, click on the link and you would get a bonus and stuff like that, just trying to access your account. So it could be a phone call where a fraudster will call you and tell you, I would send you like an OTP or something, can you call out the number to me and all that. So this has some kind of phishing and spoofing kind of fraud. So then with this knowledge, I will just jump into behavioral biometrics, how it works. So I would want to compare the traditional method to the behavioral biometric methods before looking at the workflow. So before now, we rely on traditional methods to track and catch frauds, and these are passwords and pins. So this is where you would tell a user to use a strong password or to use a strong kind of access or a multi-factor authentication and all that. So these are like the traditional method to make sure we keep fraudsters out of our account. I mean, if a fraudster does not know your login details, it's likely going to be very difficult for such fraudster to access your account. But in today's world, we do not rely on traditional way of fighting fraud using password, pins, device, and multi-factor authentication. So we move a step further using the behavioral biometrics. So looking at the name behavioral biometric, it's two unique word biometrics. Like we could say like your data, and behavioral means how you behave. So for a fraudster to get someone's password, probably by tricking them to say the password or tricking them to call out the OTP, it might be very possible by tricking people. But in the behavioral biometrics, it doesn't just rely on passwords, devices, or multi-factor authentication. It goes a step ahead, like checking the behavior of the user. So for example, let's say you're trying to access your bank account, and possibly you usually type your password at a certain speed. So let's say an elderly person typing their password at an average or below average speed, typing the password one after the other. And, the fraudster would not be able to replicate the exact style or the exact speed that the actual user is using to type the password. So this is where the behavioral biometric comes in. It's actually collect the data, the typing speed, the typing pattern. It collects it, that it compares it to the actual user data. And if there's any major differences, then it actually flag it as fraud, probably ask for more information, or just block the access. So this is like a very good way forward in the fraud solution industry. So what we have in our behavioral biometrics, we have the typing speed, the mouse movement or the gesture, probably you're using the desktop, and you want there will just be like a pattern where the authentic user does things different from how the fraudster would do theirs. So there would always be like a very different. So this is like the new method and the effective method, how we could catch fraud more effectively. We also have the swipe pattern, the pressure. When you're trying to use your fingerprint, how much did you put pressure with your fingerprint on the device and all that. So these are like the behavior of the users that we track compared to the fraudsters, and it makes it more effective to catch fraudsters. So then I'll move to the workflow. So this is how behavioral biometric works. So just like I've said earlier, it captures the real user behavior, the keystroke, the mouse, the swap, the pressure, and all that. Then it's actually analyzed the pattern using AI and machine learning to compare the behavior of the past to the current behavior and to see if it matches or if not. Then anomaly detection, this is where it actually does the work. It actually compares to see if the behavior of the actual user that was previously in the system matches the one trying to access. So if it detects that it's different, it's probably going to ask for more further authentication or just block. And if it is not, it just give access to the real user. So yeah, so that is how the behavioral biometric works. So some of the key features that we have here, we have the first one being it works passively in the background. Just like I've mentioned earlier, it is frictionless. So even the user doesn't have to know, or the user doesn't even know that something is working at the background. It is so smooth. It gives the user that perfect user experience. So it's passive, it works passively in the background, and it can't be stolen, copied, or fake easily. Yeah, just like we know, the behavior can't be the same. It can't just be the same in most of the cases. So then we also have, it also enhances security without friction, just like I've mentioned earlier. and it adapts to the user unique pattern, which means it works continuously. It's not just like a one-time thing. So once it captures the user's biometrics behavior, it works time over time. Yeah, just like I've mentioned earlier, so continuous invisible authentication during scan, possibly you're trying to scan your finger, it's just invisible. It tracks the user behavior, look at what the user have done in the past, compare it. If there's any differences, then it deny access if there is any discrepancy or if there's any major differences, and it's very, very secure and it doesn't disrupt the user experience. So I'll be moving to the benefits and the challenges. So the top benefit is that it enhances security, and that is what we are looking for, especially solution companies. We want to make sure that the user are more secure as possible. We want to make sure that their account is secure, their asset is secure. So, and this is what the behavioral biometrics does. So it's make sure that it enhances security. And the next one is the frictionless authentication, which simply means the user don't have to worry about any kind of work. You just work at the background, that the user have a seamless and a good user experience. And the next ones as a continuous monitoring, just like I've mentioned before. So it works time over time. Probably it's a login one. When you want to try to log in, it's work every time. So also the multi-layered protection, yeah, it strengthens the traditional security measures like passwords and all that. So yeah, that's true. So if it's able to capture behavior, it's then strengthen the traditional method as well. So these are like the benefits. So let's look at the challenges that we face using this kind of method. So the very first one here is the privacy concern. So in a world where in a world where users have to consent to either we using their biometric their behavioral biometric data to create solutions, and they can decline as well. So that's like a major concern, because if we are trying to build a system, a solution that is more effective, then we would also need the user to consent that we should use their data. So this is like another issue we face, where some users have a different opinion in we using their behavioral biometrics. So another one is the false positive. Yeah, just like we know that behavioral biometric, it works with user behavior. So let's say, for example, a user is in a hurry. So let's say, for example, the user did not behave the actual or the usual way they used to behave, probably in a hurry to just log into the app and do a few things and log out. So it might not be the pattern that the system, the biometric system is expecting. So in this case, it's likely going to flag the legitimate user as probably fraud. So these are like some of the challenges we face. And lastly, the data security risk. If this kind of data, the behavioral data goes into the hand of the wrong person, that's a big issue. So safeguarding it as well is another risk. So let's just finally, let's look ahead and see what behavioral biometric offer in the nearest future. What are we expecting? Since we are fostered that are advancing, moving from one technology to another, then definitely we should also be moving from one technology to another. So in the nearest future, you can expect this kind of solution to even be more advanced. I mean, in terms of adaptive intelligence, where a user is in a hurry, so it should be able to track not just a particular time frame or not just some past time frame of user data. It should be able to track when possibly the user is in a hurry, or possibly the user is in a different mood and all that. So by doing this, we're going to kind of reduce the false positive and even enhance the system using the behavioral biometric system with this future. So these are the things we could expect in the nearest future. And we also have the IoT and the mobility. So this is where, for now, what most systems use behavioral biometrics are just like a simple system. It's not like a unified system where we have a lot of systems using it. It's just like probably a banking institution, or just like a single system. So in the nearest future, we should look at we would probably see new transformation where systems are going to be interacting, possibly a bank app interacting with a car app, with a watch app, and that kind of interaction. So it's going to even strengthen the system more. It's going to make things even more accurate. In the case where your behavioral biometric is not just to be used with your bank card, where you could use it across all of your digital systems. So it even makes it even more accurate. So these highlight the kind of transformation or improvement that we can expect of the system in the nearest future. So, and yeah, so I think that's everything. So if you have just any question, you can just reach out to me on LinkedIn or through my website. So I think that's everything. So I just want to be very, very fast so I don't go over the time, because I really have a lot to, I prepared the slide to explain a lot, but still I do not want to go over the 10 minutes of the time. Yeah. So any question, any comment, just reach out to me and I will be there to answer you. So over to you, Charlene.
Thank you very much. That was really, really interesting, actually. I think the next thing that I'm actually quite excited to hear more about is the IoT and mobility. I think that's going to be really interesting, given how many devices I've got around my house. So really interesting to see how that works.
Yeah.
Well, thank you very much. And as Follows said, if you've got any questions, feel free to reach out or put them in the chat and we'll share them afterwards as well. And next up, we have Katrina, who will be talking about ethics in AI. Over to you, Katrina. We can't see you currently, if you think we can see you. Are you able to unmute at all? Or feel free to leave and come back, Katrina. Awesome. Oh. Have we got you? There we are. Fantastic.
Yeah, I think it got stage fright. How bad is that? Okay, here we go. I'm about to share. Where are we? You may need to give me the option to share again. Does it allow me to still? Yes, it does. Wonderful. Okay, let's go over to my slides. So it was really great to hear from everyone. I'm hoping this is right at the end. Is anyone still here? I think the present, yeah.
Here on YouTube.
Well, the presentations were brilliant, and I'm hoping that I'm building upon that. My name's Katrina Young, so I'll get straight into it. I know we've got 10 minutes. I'm going to be talking about ethics in AI. I just need to move this out of the way, keep getting this little sign. Okay, ethics in AI, and I'm going to be sharing my framework, particularly for ChatGPT and responsible innovation. I am actually a consultant. I'm a specialist lecturer at UAL, and I work across the board from strategy, innovation, development, and I've seen so many areas of where bias can go really wrong. So I'm hoping it will allow me to click across. It looks like it's skipping. So this is me. So just speaking a little bit more about the organizations I help. I'm going to be sharing in this presentation my best practice. I've built over 155 GPTs. These are personally across the ecosystems of the agency, the consultancy, and some recent government work that I've been doing. So I've seen a lot and I have a different approach. So these are some of my agents looking at from back end, front end. My experience does combine innovation and marketing. So I primarily look at agentic AI now and kind of package in those expertise, and I help to consult to do that. So why I started building AI differently. My background was in digital transformation. I've been consulting since I was 19. I'm older now. But I saw that AI broke the rules. I got into RPA automation around 2017, and I am an alumni of Coding Black Females, and I'm always grateful. I took the leap. And I saw that actually, particularly with ChatGPT, some people being left out of the loop, and that was people that follow the hue that look like me. So I built a new way for myself and my students to be led human first, with AI, and building frameworks that were not just technical but ethical. So my approach to GPT ethically is looking at the input mapping. So really looking at that data, the broad data. I use ChatGPT in a multimodal way. I can commute, I can create resources, online courses, all through multimodal. The latest model, I use lots of models, but it's getting far more intelligent. And I do use sentiment. I use it from a psychology basis. I use tone inputting, and I use a lot of intent. I noticed that when I use it in a multimodal way, such as images, it will say, I gave it a test to understand whether someone was trustworthy by looking at a picture. So I look at a lot of emotional tone detection. Please ignore some of the typos. I can see the images are not quite there. But I add an ethics filter, and that is by using a model called Human in the Loop. So that's logging, overriding anything that's wrong. And I think it's been mentioned, but AI hallucinates, it lies, it doesn't tell the truth. And so I've seen so many examples of it. Here is an example of, there's more examples, but this is one where I've inputted what I wanted to be done. Incidentally, I use multimodal. So it looked at ingredients in a picture being ethnic and cultural, and then started using slang, kept saying queen and all of this stuff. So I was like, stop it. I'm an educated woman. Do not speak to me like that. It's terrible. And so it came back with, it will not use any casualisms or slang. And that really, really disturbed me, in the fact that if it knows where people are from, is it providing them with valid data, or is it giving them slang? There's so many other use cases. It's taken a while to catch up moving between slides, excuse me. Am I just gonna... It seems to have frozen again, Charlene. I'm just going to see if I can see a question in the chat as well.
Actually,
Has it frozen for you?
yes, it
It's
has.
frozen. It has, yeah, it has. I keep trying to turn it off. I don't want to leave again, so just bear with me. Okay. So building an ethical framework for me is about understanding the context of the output. The lovely lady 2 sessions before referred to giving it a role. So I always identify a role, and then in a governance framework, depending on the environment. So if I'm in a business environment, in a student environment, I ensure that, you know, I understand the context. I lecture at UAL, so I ensure that there's safeguarding, that I mitigate the bias and the harm that it could cause, and then I continuously iterate and validate and improve, and I constantly check for any kind of anomalies, anything that could be given false information. We have to understand that us inputting the information or the data into these large models helps. A lot of the engineers still don't look like us. So we need to be, I believe, the reason of change, and we need to contribute to that. And ethical means making sure that we're accountable as well ourselves in the design. So when I'm looking at ethical decision making, I add layers of design. It is design thinking. And a use case here is looking at agentic co-pilots and micro agents is what we've been building. So there's an ecosystem for us. There's revenue, there's architectures. I've been building digital workforce enablers, and they've been built by AI governance. So currently, 80% of AI tools lack explainability. 61% of UK devs cite no ethics training, and that's really worrying. And only 5% of GPTs document data governance. So this really worries me that actually bias and those who are protected groups could be lost. Bias could get worse. And so for me, my ethical framework, as I said, I define the principles of ethics. So whether you're in the workplace and they have a code of conduct, I work with companies to build their AI governance. So it looks at human first. That needs to be regularly updated. You have new team members, new staff, technology is evolving. So for me, I believe that AI is missing trust, clarity, and for some, accessibility. So it's about defining the principles on what bias is. I had a class, and I would say that a lot of people still don't understand what houses in your home where you taught about biases. So that's the difficulty. It's addressing what is ethical, what is bias. And I've had a number of difficult conversations. And so for me, I like to start off first with making sure that it's about understanding the prompt and the data sets. I like to ensure wherever I am that I communicate that these need to be non-biased. The data needs to be fair and reflective of the whole of society. A lot of AI is missing this. It has bias prompting, black box outputs, poor UX for, again, neurodiverse users, and it doesn't look at inclusion. So I interlink pillars, again, looking at the input mapping, accessibility, accountability. This is an example of one of my approaches, but there's an audit flag. And if there is a trigger, one of the ladies referred to kind of hallucinations and the inputting. For all of the tools that we've worked on, we work with a legal team, and we also have we've had people trying to break and hack the AI to reveal what the framework is. So we add a governance layer, then an ethical layer, then a legal layer. So I think it's about understanding and building a human first led governance approach that adds layers of ethics and then auditing that, having feedback loops and accountability. Who's going to look after this? Because AI is for everybody, but it's not reflecting everybody. So there has to be an ethics filter. There are ways that people are using AI not for good. And so what I've done, particularly with mine, is if it does, I've got like the trigger words, the a knowledge base, and I log those, and there's a response generator to that says, here at KYC Digital, we do not support anything that, just a statement, having something like that to override. One of the other things I should say as well is having a feedback loop. So as I mentioned, when it gave that use case and it started calling me queen, ChatGPT does have the memory filter. So it's about resetting that memory, because if it's being built on inaccurate information, it dictates all of the outputs and all of the responses that it's providing you with. So another use case for one of my co-pilots is adding content layers. So it's designing it being ethical and understanding the work, the people that you're working with or the audience, and having that architecture. And I approach that from ethics built into the prompts and having kind of real-time tone moderation that I set with sentiment. So I believe that, ethics is about the foundations of AI systems, and then it should be built upon that. So it's about gathering the feedback, analyzing the metrics, and validating those outcomes. There was a question in the chat referring to the data that ChatGPT can keep. It doesn't hold on to it, but from time to time, I will test it and ask it, what do you know based on what you know about me? And there's so many conversations around that. So for me, this is happening. There's nothing we can do about it, but it is about addressing those challenges. And for me, it's about adding bias and fairness. Looking at when I'm talking to audiences that don't really understand that, it's about communicating those transparencies and then mitigating those negative impacts to those who are underrepresented, and then telling them basically you have an ethical risk. So for me, it's about mapping risks into the user journey, labeling ethical decision points, embedding DEI or inclusive. I must say DEI seems to be abandoned. So I'm kind of leading with the word culture at the moment and what that looks like, and then providing that data, login, and then flagging anomalies. And yeah, so I'm trying to keep inside my 10 minutes. Inside one of my micro agents, as an example, I'll give it the instructions. In those programming instructions, I will set the tone, I'll set the sentiment, I'll flag the negative words that cannot be used, and will drive them to a website page. They will not be able to continue use of that agent. There's a bias governance, and I've also added vocabulary and enhancements, and localisms, and there is those red flag triggers. So that's an example of how I do this. What makes my approach different is I add governance. I can provide use cases if you want. I add inclusion into design. So this isn't just about black or white. I look at making sure that there's things for neurodiverse, those with hearing aids, loops, humanistic values, and emotional insight. So a lot of my AI algorithms are actually EQ led. So it's looking at real world impact, and there's fairness. So I believe this is just a roundup. To build inclusive frameworks, we have to kind of have a technical assessment that's driven by human-centered values, defining your purpose, understanding the harm, embedding inclusion at every level, designing with consent. So we're looking at user control, privacy, prompt transparency, validating across lived experiences. So getting people from those diverse groups in the world to give feedback, and create feedback loops, because it does hallucinate, there is bias, and document everything for filter in logic. AI, it's not a chatbot. For me, it's their culture, and embedding that into code, strategy, and delivery. If you've got any questions, you can get in contact with me. I hope that was the 10 minutes. My AI agents are featured here, and you can contact me over at LinkedIn. And I'm sorry for those technical difficulties that always happen.
That was fantastic. Thank you, Katrina. Definitely a great one to end on, making sure that everyone is using AI ethically. And to be honest, I hadn't really thought of how we can use the right prompts to get it to actually behave correctly with myself, if you know what I mean. So I think that's really, really valuable that you're giving to lots of people too. And somehow we've run exactly to time. We were supposed to have 2 additional speakers, and we've run exactly to time without them. So it's been an incredible evening. Thank you, Katrina. Thank you to everyone who was a speaker with us this evening. I know it's been really valuable information. We've had people watching on YouTube and people here live as well on Zoom. But Bissy, Amma, Antoinette, Rhianette, Omar, Dorothy, Fola, and Katrina, thank you so much. And to everyone who joined us today, thank you to all of you as well. And as always, keep an eye out on what we have happening at Coding Black Females. There's always lots and lots of opportunities and loads of things that you could get involved in and be a part of as well. We'll send out the email following this, just with a wrap up of everything that's happened. But also you can find the video on YouTube if you want to watch any of it again. But thank you, everybody. Enjoy the rest of your day. And we will see you all again soon. Bye.